Hello students, today we are going to start chapter number 3, motion in a straight line. Now students, what is motion? So motion is nothing but it is the change in the position of an object with time. Means if any object changes its position, then some time will be taken to change that position. So we can say that change in position with time is a motion. Now about rectilinear motion. Rectilinear means motion along a straight line or a straight path. Now the study of motion is considered in the branch of mechanics called kinematics. Now students, we have seen or experienced many types of motion in our day-to-day life. We have seen a car moving on a straight path on a highway. That is an example of rectilinear motion. We have seen a train moving on a straight track. That is also a rectilinear motion. Means if any object is moving on a straight line, we call that as a rectilinear motion. We also have seen the objects moving on a circular path. A merry-go-round is an example of that. So that type of motion can be considered as a circular motion. Even the motion of moon around the earth is a circular motion. Then we have also seen the oscillatory motions. We have seen the example in chapter number 2 that for any simple pendulum we get a periodic time. And what is simple pendulum? So when this bob is displaced from its initial position, it starts its oscillations. So that is an oscillatory motion. Vibrations are also a type of oscillatory motion. Even we have observed zigzag motion. If a car is moving on a hilly region, then that type of motion can be considered as a zigzag motion. Or a person stepping up or stepping down on stairs, so that motion is also zigzag motion. And also there are other random motions. So these are some types of motions. Now about a point like object. When can we consider any object as a point like? So students, here it is written that if the distance covered by an object is large compared to its size, then we can consider that object as a point like. For example, if I say I want to measure the distance between the sun and the earth. So we know that the sun is a very huge object. It is not a point like object. Even the earth is a huge object. Even that is not a point like object. But when we measure the distance between the earth and the sun, we consider this sun as a point like object. Even the earth has a point like object. It is because the distance between the sun and the earth is very large compared to the dimensions or the size of these objects. Also, if there are two stars in the sky, and we know that if we want to measure the distance between the two stars, we have to consider these stars as a point-like objects. And so, when the distance is very large, then the size of the objects, we can consider that objects as a point-like objects. Now, students, mechanics is a branch of physics that we have studied in our first chapter, in that introductory chapter, that there are many branches of physics. Among them, the mechanics is the one. Now, even the mechanics can be divided into two sub branches. One is kinematics and the other is dynamics. Students, here in this chapter, we are going to study about the kinematics. Now, what is the study related in this branch of physics? So here in this kinematics, only motion is studied. The reason of motion is not studied. We know that if any object is moving, then there must be force acting on it. There must be some reason for its motion. But here we are not going to study the reason behind its motion. We are simply studying the motion and the related thing. Means when the object is in motion, it covers some distance. It has some velocity. It has acceleration. It has momentum p. So this type of things we are going to study, but not the cause of the motion. Now next is the dynamics. In the branch of dynamics, the motion is studied, but along with motion, the cause is also studied. Why the object is in motion, that is also studied. So our chapter number 3 and 4 is related to only kinematics, because we are only going to study the motion but not its cause. And after that, next chapter, that is chapter number 5, 6 and so on, they are related to dynamics. But here chapter number 3 and 4, they are related to kinematics. Now our next topic is about position, path length and displacement. But first, let us understand what is reference point and a frame of reference. Now students, suppose we consider an xy plane. So this xy plane can be considered as a coordinate system in two dimension. One dimension is x-axis and the other dimension is y-axis, and their intersection point is called the reference point, and this xy plane is called the frame of reference. Now if an object is moving from this point A to any point B, its coordinate changes. We know that any point in xy plane has its x coordinate as well as y coordinate. Similarly, if it reaches to point B, so even this point B also has its x coordinate and its y coordinate. So this xy coordinate system gives the exact position of the object. Now suppose initially the object is at point A, so we'll consider here that it is on the x1 y1 coordinate system, and after that if it moves to the next point B, then suppose the coordinate changes to x2 and y2, that means new coordinates are there. But for this much displacement it will take some time. So a xy plane is a frame of reference having a clock with it. Why clock is there? To measure the time, because time is also an important physical quantity when the motion is considered. Why? Because if any object is moving from one point to other, how fast it is moving or how slow it is moving, that can be considered on the basis of time measured. So students, I hope you understand this, that this point O is a reference point, and this xy plane, that is a coordinate system with a clock, can be considered as a frame of reference. So now reference point means the point from where the observation is taken is known as reference point. In most cases we choose origin of the coordinate system as a reference point. Frame of reference, it is the coordinate system along with a clock. And now motion is a relative concept. Why motion is a relative concept? It is because when the object is in motion, its one or more coordinate may changes with time, and when the coordinate changes from where the observation taken, that is very important. It means if any object is moving from point A to point B, then its motion with respect to this point O can seems to be different. And if any person is observing from this point O dash, that can be different. And so from where the observation is taken, that is very important, and hence it is said that motion is a relative concept. For example, suppose a train is moving and a person standing on a platform is observing the person sitting in a train. Also, there is one more person sitting in a train. So, when the train is in motion, for this person who is standing on a platform, for him this person is in motion. But at the same time, if this person is observing the first person, then for this person is not in a motion. So from where the observation is taken, that is very important. Now path length, it is the distance traveled by an object with time. Means suppose from this position, that is point A, if an object is moving on this path and reaches to point B, so this is called its path length. But about displacement, it is only the change in position. Remember students, the path length is considered for whole path, but when the displacement is to be mentioned, it is only the change in position. So here in this case, displacement is this much, straight line, the distance in a straight line, that is to be considered. So here we can say that the path length is more, but displacement is less. If a person is moving from point P to point Q in a straight line only, then in that case the path length is also this much, as well as displacement is also that much. Means the path length can be more or equal to the displacement. Displacement cannot be more than path length. Now whenever we want to find the displacement, it is always the initial position should be mentioned and the final position, and to obtain the displacement it is always final position minus initial, and for that displacement some time is taken. So for that the final time minus initial time is to be considered. Now next is path length is always positive, but displacement can be positive also, can be negative also, and can be zero also. Means suppose if this is the origin and this is negative x-axis, this is positive x-axis. So if any object is moving in this direction, that is along the positive x direction, then displacement is positive in this case. If the object is moving along the negative x direction, then its displacement is considered negative. Suppose if an object moves from O to A and then again comes back to O. So for this path from O to A to once again O, the path length is to be considered for O to A plus A to O, but displacement in this case is 0. Why? Because for that time the person is at point O only, because he moved to A and came back to once again that point. So he is here only, he has not moved at all in terms of displacement. Now students, the concept of path length and displacement can be better understood by this example, and I am sure that you will be able to understand this concept more clearly. Now suppose here an x-axis is given. You can see there is a origin O, and this is the positive x direction and this is negative x direction. Now suppose we consider this first case. If the person is moving from O to A and then from A to B, then in that case what is path length? So here you can see that the final position, this which is between 40 and 60, means it will be 50. So in that case the path length is 50 meter, because here we have considered meter as a unit of distance. So path length is 50 from O to B. But what is displacement? So as the object is moved along the positive x direction from O to B, the displacement will be positive, and so it is plus 50. Now let us see this second case. Now the path is considered AOM. So from this position, that is A, the particle is moving to O and then M, that is finally it is here. So in that case, what is the path length? So once again you can see here this position is nothing but it is minus 30, because it is between 20 and 40, so it is minus 30. But initially, where was the object or a particle? It is at 20, and so from here 20 to this 30, what is the distance? So we know that from 20 to 0, this much distance will be 20, and from 0 to 30, so this is 30. So 20 plus 30 is 50. So path length is 50 in this case. Now let us see what is displacement in this case. So now in this case we will check the displacement. So from A to M, the particle is moving in this direction. How much it moved in this direction? Again, the distance this much is 50 only, but here we have to consider displacement. So in that case, final position is minus 30 minus initial position, which is 20. Students, once again, final position is minus 30 and minus initial position is 20, because to find the displacement we have to consider final position minus initial. So minus 30 and minus 20 is minus 50. So here displacement is negative, path length is always positive. Now one more case is there, AMO. Which path? Path is AMO. So particle is moving from A to first M and then comes back to O. So in that case, what is path length? So from A to M it is 50, and from M to O, you can check this, M to O, how much it is? That distance is 30. So 50, that is from A to M, and from M to O is 30. So 50 plus 30 is 80 meter. But now about displacement. So for displacement, now we will consider only final position and initial position. What is final position? It is point O. And what is initial? It is point A. So final position minus initial, if we consider, then here you can see the final position is 0 minus initial position, it is 20. So like this. So if we'll do final minus initial, you will get minus 20 meter, and so the answer, which is nothing but it is displacement. Now students, let us take one more path, that is NBA. Now this point N represents minus 50. Now the particle moves from N to B. So how much distance is this from N to B? So clearly you can see that from O to B it is 50, because here this represents 50. So O to B this side it is 50, O to N that is also 50, so total 100. And again the particle moves from B to A also, you can see here. So B to A, this distance is how much? So it is 30, because you can see here 20 to 40 that is 20 meter, and again 40 to 50 that is 30 meter. So already there was from N to B it was 100, and from B to this point A it is 30. So total path length is 130. So I have written here path length is 130 meter. Now let us check the displacement. Now for displacement, what we have to consider? We have to consider initial position and the final position. Final position is A, initial position is N, which is minus 50. So now let us apply that formula, that final position which is 20 minus initial position is 50. So 50 is on negative x direction, so here we have to put minus. Now this minus and this minus, minus into minus plus, so 50 plus 20 is 70, and so here displacement is plus 70 meter. So I hope students you understood the concept of path, path length and displacement. Now you can check for one more path, OMO, yourself. Now about the motion. When can the motion is considered to be a uniform motion? So here the definition says that if an object is moving along a path and if it covers equal distance in equal time interval, then in that case it is said to be in a uniform motion. Now example of uniform motion is uniform circular motion, then motion along a straight path with constant speed, and even the oscillatory motion without damping. Now let us see what is this uniform circular motion. If an object is moving on a circular path, and suppose if it completes one circular path in 1 second, and if every time it completes one circular path in 1 second only, every time it takes only 1 second to complete this one circular path during its motion, then we can say that it is a uniform circular motion. Suppose the motion of a fan with constant circular motion can be considered as a uniform circular motion. Then the motion along a straight path means, suppose if a vehicle is moving on a straight path and if it covers 1 kilometer in 1 minute, then other 1 kilometer also if it completes in 1 minute, then we can say that motion is uniform motion along a straight path. Even an oscillatory motion, suppose if we take an example of simple pendulum, and if it is displaced to point A and then released, so what will happen? It will move to next point B and it will come again to A. So when it moves to B and once again comes to A, we can say that it has completed its one oscillation. And suppose the time taken for this is 2 seconds. Now if one more time, if it completes its oscillation in 2 seconds, and if the process goes on from A to B, then in that case every time for one oscillation it takes 2 seconds, then we can say that these oscillations are uniform, or it has a uniform oscillatory motion. Even an oscillatory motion. Suppose if we take an example of simple pendulum, and if it is displaced to point A and then released, so what will happen? It will move to next point B and it will come again to A. So when it moves to B and once again comes to A, we can say that it has completed its one oscillation. And suppose the time taken for this is 2 seconds. Now if one more time, if it completes its oscillation in 2 seconds, and if the process goes on from A to B, then in that case every time for one oscillation it takes 2 seconds, then we can say that these oscillations are uniform, or it has a uniform oscillatory motion. Now students, here the uniform motion is shown by graphical method. Here we are going to restrict our study on a motion along straight path and not about the circular motion or the oscillatory motion or any other type motion. Only the motion along the straight path is considered. Now here this axis, horizontal line, is representing the time in second, and this vertical line, it represents the position or the displacement. Now here you can see this is a straight line graph. Here the position of the particle is 40 meter at time t is equal to 0. Now after 10 seconds it was found that the particle is again at the same position. At 20 seconds also it is here only. So in that case we can say that the particle remains stationary at this position. It does not move at all. So that stationary can also be considered as a uniform motion. But here the velocity is 0. Motion is uniform with 0 velocity. Next example is given here. Again it is a straight line. The graph is straight line. Here also the graph was straight line, but object was stationary in that case. But here you can see that suppose the particle is here, when the time is 0 it is at origin. Now suppose after some time, let this is 5 seconds, at that time the particle is here. From the graph we can say that it is at this position. Suppose it is 10. So in 5 seconds it covers 10 meter. Then again if I'll take one more 5 seconds, that means 5 plus 5 it is 10. So at that time it is here. which is 20. So again in next 5 seconds it covers 10 meter more. So every time after 5 seconds it covers 10 meter. So here the motion is uniform motion. And so students, always whenever the position time graph, this is position and this is time, so whenever the position time graph is a straight line, the motion is considered uniform motion. Here also it was straight line but horizontal, here it is slanting line. So when there is a uniform motion, the position time graph will be straight line. Now you can see here one more graph. Here the line is not straight, you can see it is curved line. Here somewhere it is straight, but once again it is curved line. So this type of motion is a non-uniform motion, because in this case the particle will cover different distances in different time intervals.